AI and Foundational Models in Healthcare Workgroup. Today, my name is Gautam Rao. I usually lead the Phenotype Development Evaluation Workgroup, but today I have the privilege of running Martine's Generative AI Workgroup. And I'm going to use this opportunity on Martine's request to talk about the Mind Meets Machine workshop study that we had at the OHDSI Symposium on October 9th, 2025. Before I go into that topic, is there anybody new to this work group that would like to introduce themselves, or is there any other old agenda item that we should cover? There's a hand raised.
Yes, hi, I'm Matthijs. I'm new working at medical informatics at Erasmus Medical Center. So that's that to know. So with
Welcome, Matthijs.
With Renske a lot, and that's the partner of Martijn. So that's how everything is connected. So yeah, looking forward to it. All the AI stuff. Yeah.
Welcome.
Thank you.
Excellent. Ram?
Yeah, I'm not new to OHDSI, just new to the group. Thanks.
Welcome, Ram. Gaurav?
Hi guys, I'm Gaurav. I helped Gautam with the man versus machine, whatever you want to call it. But I basically just joined to help him out and talk about it today because it was really good if you weren't there.
It's mind meets machine because we are gender neutral. All right. So I have my slides here. So first of all, I'll give you an before I go into the content, I'll just orient you on where things are. Where is this? Got to stop sharing for just a second so that I have here. Okay. All right. So this is the Phenotype Development Evaluation work group. Inside that work group, Teams channel under General is a shared section that has all the different files. Here is the 2025 OHDSI Global Symposium Phenotype work group, and all the material related to this session is here. So you should have access to it. If you do not, please join this work group, and then you should have access to the content. As you see that they are numbered in a certain sequence. So these are pre-workshop planning sessions. This is where the protocols, the various handouts, the clinical adjudication files, the study results, the data, the video recording that we did, and even including the initial report out, that is the slides that I'm going to show you today, is over here. This is the introduction slide that we showed to the work group. Also, what I want to show you is the GitHub repository. So we have a GitHub repository which is under the OHDSI Studies organization. It's called the Mind Meets Machines, and this is the locked version. It's just locked before the date of the execution or before the execution start, and it has all the different content. The C01, C02, C03, and to C07 are the various clinical ideas that we worked on. The content that was shared is here, which includes the welcome, the concept set tutorial content, our analysis method, the informed consent document, the introduction slide, the Johns Hopkins University quality improvement project protocol, and the statistical analysis plan. So all of this was pre-specified in the GitHub repository and is available. The materials, these are the content that's part of the study. So you have the various concept sets that were created, cataloged in this repository, along with the script that was used for some analysis. That's here. The naming convention is C01. Anything with the C01 is the C01 to C07 is the short abbreviated name for the clinical idea that we phenotype. AI is obviously artificial intelligence, and H is humans. So if there is the humans, and then inside humans, there is the subgroup, and then there is no group. And I will explain what those are. So I just wanted to start with an orientation. Now I'm going to go into the content. All right. So the Mind Meets Machine phenotyping challenge, which occurred on October 9th, was a hybrid session. It had about 50 people that were in person, with 8 round tables and about 50 online. This was a formal experiment. We compared humans versus AI for the challenge of the concept set generations. We initially chose 7 diseases, but then we executed on 6 diseases. The 7th one was ovarian cancer. We decided to drop it because we did not have the clinical lead available for building the true gold standard. But we had clinical leads for rheumatoid arthritis, DVT, SLE, posterior uveitis, diabetic macular edema, and systemic sclerosis. So hence these were executed. The outcome was a data set which had we have both qualitative and quantitative insights on phenotyping, and we conducted a preliminary statistical analysis on that data set, and we reported that preliminary analysis on the day of the workshop. The workshop started from 8 a.m. in the morning till 12 p.m. in the afternoon. So what was our objective? Our objective was to scientifically compare human workflows versus multiple autonomous generative AI pipelines. So the human was, as you know, is also highly variable. And so we decided to make it such that a group of people work together and build one concept set. And to do that, we created a framework which we called as split and reconcile. So people were assigned through random allocation to a clinical disease, and they were then split on that table to work separately to build a concept set. After some time, they were asked to reconcile, and the reconciled output was used for the comparison, and that was the human's contribution. So we believe we have the best concept set created by humans through this workflow. The autonomous generative AI pipelines submitted their concept sets prior to the start of the work group. So most of them were submitted on the day of the symposium, that was October 8th, 2025. The primary metric that we assessed was what is called as the prevalence weighted F1 score. It's essentially an agreement to a blinded true gold standard. So there was something that called a true gold standard, a list of concept IDs for that concept, for that clinical idea. So I'm going to explain how we created the true gold standard. The true gold standard was created during the workshop. It was not previously generated. It's called prevalence weighted because not all concept IDs are equal. Prevalence comes from the OHDSI network. So every concept ID we have a count of its representation across the OHDSI network. So if a concept ID is present a lot, then it should be given more weight. And if an arm misses a concept ID that is present a lot, then it will be penalized more compared to missing a concept ID that is present or not present at all in the network. Present less or not present at all. So that's why it's called a prevalence weighted F1 score. So the methods, we have one human benchmark arm, and we had 4 AI arms that were independently submitted. Now, the input for all of this were exactly the same. We released the standardized clinical descriptions through OHDSI forums and the GitHub repository and via email at the same time to both arms, the human arm and the AI arm, which was the Sunday night before the symposium. We had also asked everybody to fix the vocabulary version to the release of August 2025. And we had pre-specified that this is a blinded. We would develop a blinded adjudication. So that means that even the adjudication algorithm would not know what is it comparing. So some of the key takeaways: the performance did vary by disease. That was interesting to us. And then there was a lot of qualitative discussions about the complexity of building concept set, like what is an unambiguous input specification, what is a clinical idea that should be a concept set versus that of a cohort definition. And so there were some discussions that the clinical leads and the participants expressed. So we'll talk about that. So going back, why did we even do this experiment? Well, this was part of the OKRs for the Phenotype Development Evaluation Workgroup. We wanted to evaluate if generative AI for concept set development. So we had pre-specified this as something that we wanted to achieve in January 2025. So we divided this experiment it's a mixed method study to inform the phenotyping process. And based on the final results, it's going to let us know if we should invest more time in this technology for the purpose of robust, reproducible phenotyping. We had several secondary objectives, which we have not done analysis for so far, but we had the primary objective, which I described, which is the prevalence weighted F1 score. The secondary objectives was to compare the baseline variability across arms. So we have so many arms. We have 4 AI arms, and we had 1 human arm. But even inside the human arm, we have the subgroups. So we are able to understand if the split and reconciliation method of humans actually improved the quality compared to the true gold standard or worsened the quality. That's interesting observations. We are able to do that. We're also to do some qualitative analysis on the what happens when there's disagreements and so on. So the study design, multi-arm comparative design, 1 human, 4 AI arms, split and reconcile, as I said. Now we did when people came in, they had, as you can imagine, different levels of expertise in building concept sets. There were individuals who have never done concept set building before. There were individuals who do concept set building on a daily basis. And then there were people who build concept set once in a while. So we asked participants as they entered to self-identify their level based on a structured description. And if they identified themselves as experts, they would be flagged as expert and they would be given the expert color sticker on their name tag. If they were identified as not experts, but but know something about concept set, they would be given another color. And if they were considered to be not knowing anything about concept set, which was actually the vast majority of the people, they were given a different sticker. Now, individuals who identified themselves as not knowing anything about concept sets were considered observers. They were not randomized to any disease tables, and they were allowed to float around from one table to the other. They were only asked not to influence the concept set building done by the other 2 groups. Now, the other 2 groups were randomly assigned to the tables, to the disease tables. But we assigned them in such a way that they always sat next to the person with a different color. So an expert would sit next to not an expert. The humans who build concept sets were allowed to use any Odyssey tools that they want. They were allowed to read any clinical books that they wanted. They could even talk to the clinical experts in the room, because every clinical arm had a clinical expert who was a practicing physician a board-certified physician in rheumatology and a board-certified physician in ophthalmology, a hospitalist, and so on, were practicing physicians, experts in the field, and they were available for consultation for the participants who built the concept sets. The clinical leads did not build concept sets. They were only available for consultation. They were explicitly instructed by the investigators to not provide guidance on codeless selection. They were only allowed to provide clinical input about the ideas behind the clinical description. Now, the clinical leads were told the clinical description as written is the guiding document, and they were allowed to interpret the document based on their experience and expertise, but not introduce new ideas. AI tools were prohibited in the use by the humans building the concept sets. Now, for the generative AI workflows, the rule was that it had to be an autonomous execution. By autonomous, we meant that there is no human in the loop editing. So they could prompt and reprompt, and they can sequentially prompt. That is fine, but they were not allowed to manually change a concept set expression. They were also asked to do a methodology documentation with their submissions. One more comment about the generative AI workflows. We had 4 arms. 3 of them identified themselves. 1 of them asked to be anonymous. So we had one arm, which was represented by the organization EPAM and the tool Prometheus. It is a proprietary tool for cohort generation and concept set building. There was another arm that was represented by Johnson & Johnson, by Joel Swerdell. It's an open source tool that is still that has not been released to the public yet. And then there was third arm, which was represented by Nico of I forget his organization name, but he's a PhD student.
The Queen University.
Thank you. So he did his work, and the fourth arm will stay anonymous. As of right now, all the arms are identified as AI1, AI2, AI3, AI4. We will not be releasing the names of the key, what's AI1, AI2, AI3 till after the full analysis. After the full analysis, the anonymous arm will be named as anonymous. All others will be named by their organizations and the participant names. So we want to talk about the adjudication. How did we come to this true gold standard? How was that constructed? So what we are adjudicating here is the concept IDs. Our primary analysis was to adjudicate standard concept IDs. It could be from any domain, but it had to be a standard concept IDs. So we did not adjudicate non-standard codes like ICD-10-CM. It would mostly be RX norm and SNOMED codes. For the adjudication, we also did not adjudicate the structure of the concept set expression. We wanted only the resolved set. So we are looking at a long list of concept IDs. So step number 1, we have 5 submissions for every clinical idea, 1 from the human arm and 4 from the AI arm. We took the union of all concept IDs across the 5 arms. So now we have the concept IDs from the AI and human in a long list deduplicated. We then looked at an intersection of concept IDs across the 5 arms. So that means they should be present in all 5 arms. If they were present in all 5 arms, they are considered a universal agreement and they become gold standard by default. Anything that does not have universal agreement is obviously disagreement, and that is subject to human expert validation. So the clinical expert who was pre-specified, the practicing physician, would then do an adjudication. But they are blinded to where that delta came from. They do not know if this concept ID came from the human arm or an AI arm, or both the human and the AI arm, or how many AI arms and how many human arms. There's only one human arm, but they don't know how many arms did it. But we did sort it based on degree of disagreement. So more disagreement, higher on the spreadsheet list, and the prevalence in the concept prevalence across the OHDSI network. So essentially, top of the list was those with the most disagreement and the most frequently occurring, and the bottom was least disagreement and the least occurring.
Maybe Gautam, I can just clarify this point. That was just because we were worried that we would run out of time. So we wanted the adjudication real time happen on the most things that are going to affect the score. But we eventually ended up, the adjudication happened down the full list in all cases. So everything got adjudicated. Yeah, but we sort them in a way that we get the disagreement adjudicated priority in case we run out of time.
Yep. Thank you, Azza. How did we organize this event? Well, we did the initial. It was 4 hours, so we did the welcome. We stated the objectives. We randomized in participants across tables. We obtained written informed consent from the participants. We described to them that it was a timed event, and there was a dedicated Atlas instance that with concept with vocabulary of August 25, and they were timed. At exactly the end of the time, the Atlas was automatically locked and no further edits could be made, and it became read-only. After the 1 hour of humans building concept sets, the technical team prepared the preliminary results. And as they were preparing the preliminary results, we had presentations from the 3 identified AI leads, and each one of them presented 10 minutes. After they presented, we showed the preliminary results of the agreement and disagreement across the arms, and that we call that as the phase 1 results. The results showed that there was variations, and that certain diseases has more agreement and certain diseases had less agreement. And that led to the creation of the adjudication sheet. Adjudication sheet was a spreadsheet that was put into the Microsoft Teams environment and was given to the clinical adjudicators. The clinical adjudicators then led the discussions for the next 1 hour. So they were at the head of the table, the 6 tables, and the participants were allowed to sit around them. The participants did not make any changes to the spreadsheets. The clinical leads made changes to the spreadsheets. The spreadsheets had an indicator variable which they had to say yes or no based on the consensus with the participants. The guiding document for the adjudication was still the clinical description. One of the participants was asked to be an honest broker. So the honest broker was responsible to hold the clinical lead accountable. In other words, if the clinical lead makes an assertion that a concept ID is included, then they would ask why. And if the rationale behind it was something very remote from the clinical description, then the honest broker would then assert that determination is biased. An example is if a clinical adjudicator asserts that a code is appropriate based on their local institutional practice, that is not acceptable because that's not generalizable. So we had 1 or 2 instances where the honest brokers did intervene with the clinical adjudicators. This is showing you the tally. As I said, vast majority were observers, and we had a limited set of participants. Those limited set of participants were assigned to the tables. We had a reasonable blend of experts and those not experts or familiar with concept set building. So this allowed us to do the split. And when we did the split, each split had an expert. except the SLE group where we had to provide some assistance. But we were able to ensure that each split had an expert who was familiar with the concept set building process. And this was by design because we expected the two people with similar colors to sit next to each other. And that allowed us to split. During the reconciliation process, one person in the table was named as the expert, and they were required to create the concept set expression. Now, to ensure that we had, say, standard naming convention, we had pre-populated placeholders for in the Atlas instance with concept sets that had a certain prefix that allowed the analytic team to identify the concept set expressions for analysis. We do not know, we have not linked the individual participants to what concept sets they have built. So there is no linkage between persons and the concept sets. So this is a slide that talks about the various AI methods, each one of them presented for about 10 minutes, about what methodology they used to build their concept sets. This happened after the humans built the concept set expression. In the AI method, so this is the EPAM group Prometheus software, a proprietary software. So they used then a Cloud 3 Sonnet-based LLM which queried a vector store of vocabulary tables and did a semantic retrieval. It has a user interface that allowed them to adjust the precision and so it can extract based on that numerical value on a similarity scale. So that was some configuration involved. It did produce a narrative explaining its rationale and scores. So Daria Zulkova presented the Prometheus, and all of these have been captured in videos, and we will at one point edit it and put them on YouTube. Nico presented from Drive Health. He presented a very creative approach, I thought. I've been thinking about knowledge graph in the OMAP, and I was very happy to hear about the work that Nico was doing. So he used a combination of semantic search with knowledge graph from OMAP's relationship tables, that is the concept relationship table. So it provided a level of richness that I think Atlas concept set expression does not. So he used a combination of semantic search and relationships to traverse the clinically similar concepts, it explained the rationale behind it. So that was pretty impressive.
And Gautam, his work is already in Git, right? He shared his package, I think.
I don't think so. I think he's planning to open source it, but he has not yet done it. So he was still working on it. So the backstory about Nico, I told him that I'm going to make fun of him, so he did. So he thought the submission was after the end of the symposium, that is the evening of October 9th. Well, the October 9th morning was the event. So the submission due date was the day of the symposium, which was October 8th evening. And so he built this out starting 6 p.m. on October 8th. And at 2 a.m. I received an email with the concept set. All of this was built on his laptop. And that was pretty cool too. The next method is from Johnson & Johnson. Joel Swerdell presented it. He also had a very creative way of doing it, where the clinical idea would be represented by one concept ID from SNOMED, and then it would bring back recommended concepts from Phoebe, which is the concept recommender in Atlas. And then an LLM would adjudicate each of those based on some criteria and provide a numerical score of whether that code represents the clinical idea. And that numerical score is based on the LLM's pre-trained knowledge. And they iterate across the long list of concepts, asking the LLM, do you agree? Do you agree? Do you agree? And is it above a certain threshold? And I believe that's how he creates the final concept set expression. The reason why I bring this up is obviously the fourth method is anonymous. I know what it is. I have the slides, but just because it's anonymous, I'm not going to reveal it in this talk. But what you see here is the three different AI methods are different. They're different styles and different techniques to come up with the concept set expression. So we did some preliminary analysis. There was obviously very highly variable across diseases. I'm going to.
Yeah, maybe you can show the overlap. Just that's the agreement between the approaches, not the performance of them.
Yeah. So this is the different clinical diseases. So this was presented on the day of. This happened around 11 o'clock after the humans created, and then the AI group presented their methodology. We showed the overlap. So this whole length would represent all the concept IDs, and they're present in one is the orange, present in one arm only, and present in both arms. So you can see in uveitis, the amount of automated overlap intersect was low, but in some the intersect was high. We also looked very quickly on what happens when humans do split and reconcile. A positive number indicates that it improves, and a negative number shows that it declines. So we see some variation there. This is the pairwise comparison of similarity between the various arms, the human versus AI1, human versus AI2, human versus AI3, and so on. So that just shows you the Jacquard similarity score by diseases. All of what these are saying is there is variations, and you can see some of these have more variation, like DVT had lots of more variation compared to the colors of systemic sclerosis, for example. Go ahead.
No, I just wanted to, because you're going quickly over the thing. Basically, in rheumatoid arthritis, and you'll see it here, there was pretty good agreement across all arms. So if on a high level, and here I think what we did here is that we put all the AI together as one arm using the union of them and compare them to the human, and you'll see that even when you do this, which is like you're putting all the AI together, you still see that you have a high overlap. I think it was 94% or something, and only the AI is bringing a little bit more, and the humans are bringing a bit more, less than 5%. So it was a very narrow list that they have to adjudicate for rheumatoid arthritis.
No.
Yeah.
Even if there was there are 4 AI arms, because this is the union of all the AI arms, we're seeing this pattern.
Correct.
Even if 3 of the AI arms agree and 1 disagrees, then it goes to adjudication.
Correct. Sorry, you'll say sorry. That's right. But even though you still have 90% agreement, regardless. So it's still the case. Yeah. And then, but if you look at deep vein thrombosis, which actually was not, it was proximal deep, so it was a little bit more granular than DVT. It was a more tricky disease than any DVT. Can explain that you have the overlap was less than 40%, meaning that more than half the codes was not present across all the different arms and need to be adjudicated. And in some cases, the human is bringing additional codes. In some cases, the AI is bringing additional codes.
Yeah. So here, systemic sclerosis, AI is bringing additional codes, very little from humans. But in this case, in uveitis, you can see humans bringing more code than the AI. Yeah. Okay. So this is before we have gold standard. Only after we have the gold standard can we do the F1
Maybe
scores.
maybe you want to pause and see questions.
Yeah, I can't see anybody. Is
Yeah,
anybody
I know,
asking?
no, but we talked a lot. Maybe you want to pause before you go more deeper into the results and see if there's any question on the calculations, on the method, on the anything. Does it make sense to people?
So this is not prevalence weighted though, right? At this
No,
point?
here, yeah, this is just the crude results of
This is
agreement.
just, yeah, this absolute numbers. Okay.
And it does not
Which-
have, this isn't pre-gold standard.
Pre-gold standard, yeah, it's not adjudicated at this point. It's just, these are just strict numbers.
Wasn't there a graph that showed that for like rheumatoid arthritis or something, one of the uveitis, there were very few, like a really small bar. Oh yeah. Oh. There was a very small blue bar for uveitis and a big bar. And then, but down at below, you have, it's sort of the other way around. Yeah, this one. So like this one.
So so there is a caveat here. We are still cleaning up the code. This is extremely preliminary analysis that was done in real time. Some of these have been named incorrectly. So we need another 4 or 5 days to actually validate the code. So I'll walk you through the process. This is preliminary analysis. We might redact many of these findings and override it, but the results are already the codes and the adjudication files are locked. There's the analysis script. We have to cross check because there might be some errors in this as of right now. So I have not looked at it in that much depth yet.
Yeah, but this is deceiving because you're looking across all the AI arms. So now you put them all together and you compare to the human, it might look like it's performing in a certain way, and the overlap. But yeah, it could also be, we didn't yet look at we put the formulas, but we didn't see how they're coded. So we might need to look back.
Okay.
Yeah. Richard?
Yeah, thank you. No, the presentation is really clear. There's just two questions I think that come to my mind. And I was curious about the conversation that you all had around the weighted F measure where you were doing the prevalence weighting. The way you described it earlier is that something that's really common, a term, a concept that's really common across the OHDSI network is going to be kind of highly weighted, and something that's kind of infrequent across the OHDSI network will have sort of a lower weight. And intuitively to me, I feel like if the concept is valid and it's kind of got a low prevalence, it's actually kind of a big deal that one of the two methods would have picked it up, because then it means that you'll have greater sensitivity without a loss of precision, at least at the site that has that code. So I wonder if there had been some discussion around that. And then the second question I have is, did you all use or think about using inter-rater agreement? Because when you're pulling together these AI methods into a single batch, it might have made some sense to do sort of a kappa calculation between the AI methods. Is that also included in your analysis? Because you hadn't mentioned it.
Yeah. So
thank you.
So Richard, I think that's a very good feedback. So the way we want to operationalize the analysis is we have described at a high level the methodology, but we will double click on it and go into more detail as a work group as a combination of phenotype work group and generative AI work group. We have scientific advisors, Martin Shumi, Patrick Ryan. We are all going to work together and hopefully to define the exact final methodology that we will use for analysis. So we are trying to figure that out yet. Our initial idea is just data quality right now, to making sure its quality is good, it's been captured, that we have some crude characterization results and some high level preliminary analysis. That's the goal for this week. The next week we'll convene a more detailed analysis plan. So our goal is step 1, and I'll describe this again later. Step 1, clean up the code, make sure the one that we did very, very fast is actually valid. and then have it independently reviewed by somebody who did not participate. So another Odyssey collaborator, Jamie Gilbert, who's maintaining code diagnostics, has volunteered to look at the code independently to make sure it is valid. And after that happens, so first step, I'll get the code, I will review it. Then Jamie Gilbert will look at the code, he'll review it. And then we'll do the scientific group and to figure out our definitive analysis method.
Thank you. And
Yeah.
I was unable to make the symposium, so if I can help in any way too, because I'll be sort of independent in that context. So thank you.
Joel?
Yeah, so I was wondering whether you were planning on also to do a non-prevalence weighted analysis, similar to what kind of Richard was getting at, I think.
Yeah, yeah.
Because sometimes these apps, just to look at absolute codes, you know, just because it's not a whole lot of people in there, this is more of a, I don't know. I guess I think of it as more of an idea of whether the code should be concluded or not, regardless of how many people are in there. Yeah, I mean, how many people are in there is important, but you know, vocabulary changes and things like that makes a code that might be ill-used today highly used tomorrow.
Yeah, and I think what needs to be so originally before when we're planning this, we put a very short analysis plan that is basically centered around calculating the F-score as a measurement of performance of accuracy compared to the gold standard, and then with the idea of weighing, because we all have the knowledge that there are many codes, but the ones that actually materialize across the data sources is only a subset of that. So the impact might be different, but again, that might be an oversimplification and not maybe, and it will be different depending on what vocabulary you're looking at and so forth. So I think the right way to do this before we look at the data, I think we should still calculate the metrics that we said we're going to calculate as part of our analysis plan. And that includes the crude F-score and the adjusted F-score. And that goes every arm, because Richard mentioned that every arm compared to the gold standard. So the human compared to the gold standard, AI1, AI2, AI3, AI4, separate. And then we could do basically an averaging using some mixed model to get to the overall performance of the AIs by just averaging them, weighing for the different components. There's some language there. I think we should do that. But before, and maybe what we need to do, Gautam, is put this in the community to say, like, what is what analysis we can do in this as part of this. In the workshop itself, people said, why don't we run those phenotypes now in the data and see how different the populations are? Why don't we create phenotypes using those as an earliest event, for example, and run them through phi-evaluator to see is there any evidence in the data that those patients have better, those codes have higher or lower sensitivity, specificity, and so forth. So there are additional ideas of what to do to the data, but I think the initial step is to first make sure that the overlap calculations are correct, the F-score calculations are correct, and then do do weighted and crude, and then see what else we can calculate in addition to those as part of this experiment.
So I will show you the phase 2 results. So this is again extremely preliminary. We have not validated this, and we have not come to a conclusion. So this is the number of concept IDs that were present in the gold standard concept set. That gold standard is a spreadsheet that you can find in the materials. So here is the gold standard adjudicated file that's currently locked. So it has 34, 63, 199, 204, 34, 51 concept IDs. So now we are comparing every arm, human 1 to gold standard AI1 to gold standard AI2 to gold standard and so on. So we have not finished that analysis, but in this is what we had shown on the day of the workshop in the last 1 minute. So just bringing it back. What this is showing, the higher the number, the more the agreement with the gold standard. So for systemic sclerosis, there was a 0.997 agreement for the human concept set with the gold standard, and 0.83 for the AI with the gold standard. For DVT, the 0.67 for the human, 0.72 for the AI. For the posterior uveitis, it was 0.67 for the human, 0.75 for AI. And rheumatoid arthritis, 100% with the human and almost 100% for the AI. Exactly the same for diabetic macular edema and slightly better in the SLE arm. Now, this is AI as a group, not AI as individual arms. That has not been done yet. So we're still trying to figure out, we're still trying to do the analysis. It's not incomplete. But if this holds true, it's saying, I think, and don't quote me on this because it's again preliminary, that the AI as a group versus human as a group, there was maybe, if you combine across all diseases, the AIs did pretty well. That's the general take. Richard?
No,
So just some wording for clarification, because I've heard you say twice now when you've talked about these results, agreement, but it's an F measure is not going to give you agreement.
no, it's not. It's meaning
That's-
agreement to the gold
The
standard. Yeah.
agreement is like,
Performance.
so F measure is meant to be a balanced capture of precision and recall. Can you show the formula? Because basically what the results are saying in the very preliminary sense is how well each of the humans versus the AI performed when you balance precision and recall. And usually a weighted F measure is going to weight recall over precision or precision over recall if it's a weighted measure. Otherwise, those things are equal. So can you show the formula that you use for the prevalence weighted F measure? Because I really don't understand what that is.
No, it's what you said, Gautam. It's in the protocol, and it's not weighted. It's given the same value for recall and for precision. It's just weighted by the record count of the code, whether it was absent, it's missed or a gain. So Gautam, it's in the protocol, the formula.
So you're saying instead of counting like a true positive, it's going to be some number between 0 and 1 times 1. Some number between 0 and 1, which will reflect the weight of that across the site, and that's going to be the same in the false positives, false negative sense as well. Okay.
Correct.
Yeah, I'll have to see that formula because that's.
Yeah.
Yeah.
We did the.
I agree in the final analysis. You should do an unweighted one because I think it's a confusing concept for those of us who know information retrieval metrics.
Yeah, let's. That's why we can work together on it.
Yeah.
For sure.
Definitely, we did this last minute. We just
And no criticism. It's excellent. I mean, it's beautiful work. No. I was just trying to be. But when you say agreement, instantly I'm thinking of agreement, which there's no gold standard in agreement.
No. He's misusing the word.
Katie?
Yes, I'm wondering if it has to do with the pooling of the means of the AIs in this table versus like the crude results you showed above. But some of these, it looks like, both the human and the AI agreed really well. Sorry, not agreed. F1'd really well. But in those charts where it shows like there's a bunch of AI only concepts, how does that reconcile with this? Like, for example, in SLE, I remember there was a big chunk of AI only concepts, but then how do they both have a similar F1 score?
So that was my initial reaction when we saw the results on Thursday. There's one of 3 scenarios. One, that we have a bug in the calculations. Could possibly be the situation. Number 2 is pooling the AI together is doing something. Maybe they're performing differently and it's messing up. A third scenario, which is the simplest one, is all these things that they disagreed on or was not present, that the pool overlap has very, very small record count, and so many of them are many of them are actually zeros, which possibly could be the case, which is why you have a high F score in both cases. But okay. I can't tell. I can't tell this is absolutely wrong. There could be a scenario that they are true, and the record count is basically what happened in the insight that happened when the human split and reconcile. One of our participants, Mitch, when he reconciled with the other part of the table, he was like, "Oh my God, we have so many concepts that are not the same." And he freaked out because we were timing that they have to reconcile quickly. And then when they looked at the record count, it was all zeros. So it didn't matter for him. So it could be that those extra, by extra, I mean they are green or pink in the previous diagram, but actually had zero records.
Got
Or
it.
many of them had zero or low, which wouldn't manifest like that. But we don't know. We have to do the quality check first.
Yeah, makes sense. Thanks.
All right. So final reflections.
Joel, that was his hand up.
Yeah, just real quick. Do you know whether when the humans were creating their concept sets, whether they were being influenced by the record count?
Yeah, so the record counts, so the humans were allowed to look at the record counts on atlasdemo.odyssey.org. We had put some we were trying to put record counts in the Atlas instance where that was being used for the experiment. We had successfully done it, but in the last minute somehow it went back to the dummied fake data's record count, and I couldn't get the true data record count. But they did have access to Atlas demo,
And they used that.
and they
At
used
least
it.
two tables used that. The expert adjudication did not use that. So they were adjudicating the concept on its merit,
makes sense.
not related to its use or utility. The other thing that Gautam didn't mention, and maybe I don't know if you Gautam can bring an example, but one of the insights that the participants came with is how much a lot of the ambiguity from what they're used to in their real world practice in generating concept, how much of the ambiguity was resolved by having the clinical definition or clinical content pre-specified to them in their hand. And that's because it wasn't just the clinical definition, it included the exact clinical research question that the phenotype or the concepts are being used to. So we fully specified the research question, that the concept set is used in what phenotype and used in what research question. So they understood, is it an outcome? Is it a covariate? Is it whatever? And it seems like this helped them a lot in the exercise. It also, the clinician said that really helped them a lot adjudicating, knowing what is the exact analysis utility of the concept set, which I'm one of the people who always argued that it shouldn't matter if phenotype is a phenotype. But there was a lot of comments about how it helped a lot adjudicating and selecting. The other insights that came out of the discussion, also from clinical adjudicator, where it is hard, and that because also Joel showed his prompt, what is exactly the question they're trying to answer? Are they trying to answer, is this code is rheumatoid arthritis? Or are people with this code more likely to have rheumatoid arthritis? And you can think of it that those are two different questions. Because if you're generating a concept set that is intrinsic to that label, you're just trying to say if this is rheumatoid arthritis or not. But if you're just trying to say, can this code capture rheumatoid arthritis, then you can think of a diagnostic work or a comorbidity or something that is very specific to rheumatoid arthritis is a legit code to exist in that concept set. And so it was really they differentiated between what is the concept set job? Is it to identify people with the label, or is it to just define that label? And that's the idea between what is a concept set and what is a phenotype. And it was very interesting to hear them talking about it.
Yeah. Ram?
So I just had a quick question. Please forgive me, it's going to be silly to ask, but when we think about like the ones that performed well, at least preliminary, we had rheumatoid arthritis, and I forgot the other one, but those are pretty common. I think diabetes, those are pretty common ones. So the corpus or the data set that it's trained on, there's a lot of information to balance out the sensitivity, right? So then my question comes back to you. It's like the other ones, again, a silly question. The other ones might not have had enough data from in the corpus from a data set perspective for the training for the large language models. Do you think that impacted it? And is there any way to like take that into account from a results perspective?
Yeah, so the only, well, I think the different arms use different LLMs. I think Prometheus used Claude Sonnet 3.5, and Joel, you used OpenAI's endpoint, maybe,
4.0, yeah.
and Nico used a local model on his laptop. So we do not know the impact of these models itself right now, but we will look at agreements and disagreements between those arms, and that'll help us.
That's a great question, though, Ram. I'm going to look at that for my thing, my concept set builder, to see if there's difference. If it has better performance on common diseases versus less common disease. Interesting point.
It's,
Yeah.
We have 1 minute and we have Wojtek.
So if you want to need some closure, I can go after it's a comment. So I meant the comment is related to, it's not really a question. So at some point I wrote a paper called Terminologies Coming of Age, and I judged the terminologies by number of new concepts and number of like new parents they introduce. And if they stop introducing new parents, maybe they are maturing and they are capturing medicine well. So I wonder, one thought I had is what percentage of concept sets are, if I would define a property called expressible, where you can express it as some sort of children of some concept, with the exception of another children, where you don't have, as opposed to enumeration, where you just, as a human, you enumerate. And some concepts as by nature are like nothing like medicine has seen. It's really a random collection of codes, versus it's a collection of code which infers some clinical idea. And heck, this idea should be already built into the terminology, and maybe it should already be apparent. Otherwise, the terminology is not mature. So I wonder how it would perform on things like procedures and measurements, where even some units may matter, or like methods and stuff. So it was only done on diseases. And so if we just try to, I don't think over long term we will end up with AI creating concept sets for us. I think it's more like AI will take over the management of terminologies. If AI already led all the literature and said, hey, build a better LOINC, forget the LOINC we have now and build a better one, it might end up with a better relationships and better definition. So just some thoughts on this expressibility, and maybe this factor of maybe our terminology hasn't really matured.
Yeah.
If we really need the
Yeah,
concept sets.
just to add to it, so Judy Rakusen made a similar comment about expressibility. So we had acute proximal DVT of the leg as the clinical idea, and from a safety scientist perspective, that really doesn't mean much, because why that one local anatomical area, plus that just basically makes it very difficult also to describe, because of the expressibility of DVT, because it just says DVT, it doesn't say the anatomical area. How do you handle those? So there was definitely a comment about that was similar from her. That's a valid point.
Yeah, I mean, great work, big fan. So I just wanted to comment, if we write discussions and need some closure stuff, these were some of the things which came to mind.
Right. So the timeline that we are trying to do, we are on a pretty aggressive path. So we will do the internal reviews by the principal investigators. We'll make sure that the code is reasonable. We'll have an independent review by Jamie Gilbert, and then we'll have a scientific review with Martin Shumi and Patrick and Richard. If you are interested, or whoever else wants to join from the community, we can work together on it, and we'll think about the final analysis plan. But right now we are here in step one. So the timeline that we're pretty aggressive. We want to have the first draft of some paper by the end of this month, if possible. And we had talked about a grand plan of Phenotype February 2026, where we'll do an experiment at the phenotype level, not at the concept set level. But that's a grand plan that's still to be discussed. So various types of analysis, and would love to know about anybody who's got any feedback on the way this experiment was conducted as a workshop session, and looking forward to working with all of you on future collaboration. Thank you, guys.
And we don't want to, I keep forgetting thanking Gaurav for all the work we did in the back end, getting all the calculations. Thank you, Gaurav.
Gaurav has stepped up as a new Odyssey leader, and I want to thank you and recognize you, Gaurav, because without you, this could not have been done. He was rapidly on calls with the backend team, instructing and coordinating between what was happening on the ground there in the workshop, the online 50 people, what they were doing, and the team that was extracting data and analyzing it, giving them feedback on WhatsApp calls across continents. And so that's kudos to you, Gaurav, for organizing it.
Thank you.
Great
See
work.
you guys.
Bye.